Clement alias, and I am from section 2B, Group 4. We have chosen Sultan Azlan Shah Power Plant as our thermodynamics project. Tenaga Nasional Berhad, or TNB, is the largest electricity utility company in Malaysia, with an estimate of RM71.4 billion worth in assets. TNB has 38,000 staff to serve a customer base of over 7 million in Peninsular Malaysia and Sabah. TNB core business comprises of generation, transmission and distribution of electricity, with a total installed generation capacity 12,000 MW, including Sabah Electricity, Sdn Bhd and Kapar Energy Ventures. TNB contributes to 55% of the total industry capacity through 6 thermal stations and 3 major hydroelectric schemes. By the middle 2000, the system generation capacity had to be increased to 40,000 MW because of the demand of people in Malaysia. There are 2 coal-fired power stations in Peninsular Malaysia, but we have chosen Sultan Azlan Shah Power Plant, a coal-fired power station project in the district of Manjung in Perak Darul Rizwan. This is the schematic diagram for the coal-fired power station. Next, let's proceed with the net power output. The Sultan Azlan Shah Power Station, which has a generation capacity of 3,100 MW. 3,100 MW comes from 3 units of subcritical power plant that are called Manjung 1, Manjung Unit 2 and Manjung Unit 3. Were constructed in July 1999. In 2011, Manjung 4 was constructed, which is an ultra supercritical first in Southeast Asia. It can generate 1,000 MW. Both boiler and the steam turbine are being manufactured in Asia. The ultra supercritical coal-fired power plant gives more efficiency than subcritical, meaning that it can generate more electricity with the same amount of coal. Sultan Azlan Shah Power Plant consumes 50 million tons of sub-bituminous coal per annum. And this is the image of 3 unit subcritical power plant that is constructed in 1999. The second one, this is the image of 1000 MW ultra supercritical coal-fired power station. The type and amount of fuel. Coal is the most abundant fossil fuel of the planet, with widely used as the source of energy in thermal power station, and is relatively cheap fuel. Coal is an impure fuel and produces more greenhouse gas and pollution than an equivalent amount of petroleum or natural gas. Major coal type that has been using in the power plant are subbituminous and bituminous. Subbituminous generally used for electricity generation. Subbituminous coal contain 35% to 45% carbon, and bituminous containing the widest range of carbon content, which is 45% to 86%. Bituminous is mainly used as a fuel to generate electricity through some it used as coking coal to produce steel. The plant can burn either bituminous or subbituminous coal with a calorified value ranging from 5,000 kCa per kilogram to 6,600 kCa per kilogram. Moisture content of 9% to 35%, sulfur content of 0.1% to 0.94%, ash content of 1.5% to 13.9%, and fixed carbon content of 35% to 54%. On the left side, this is the example of bituminous coal, and at the right side, this is the example of subbituminous coal that has been used in Sultan Azlan Shah Power Plant.
The electricity produced by the generator is transferred to 500 kW grid via a main 3-phase core-type transformers. The high voltage outgoing lines are connected to the 500 kV switchyard substation. A isolated phase bus bar ensure the connection between the generator and the main transformer, as well as the tap connection to the unit transformers. In normal operation, the 11 kV network is supplied by the unit 3-phase transformer from the generator 23 kV bus bar. The electricity is supplied to the unit auxiliaries at the different alternating current voltage, which is high voltage to the main motor, medium voltage to the medium motor, low voltage to the small motor, and lastly low voltage to the lightning and small power. For the mechanical equipment that used in power plant is condenser, which is single pass surface type. Second, condensate extraction pump, which is 200% motor pump set multi-stage vertical type with barrel. Third, circulating water pump, which is 50% concrete volume type main cooling water pumps that cooling water from the sea to the three condenser. Fourth, feed water heating pump, and last but not least, feed water pumps. For the sulfur oxides, emission of sulfur oxides result mainly from the presence of organic and inorganic sulfur in the fuel. During combustion, by far the majority of sulfur oxides are produced in the form of sulfur dioxide. For solid and liquid fuel, 1 to 3% of the sulfur is oxidized to the sulfur trioxides. This reaction is catalyzed by transition metal. For the nitrogen oxides, the principal oxide of nitrogen emitted during combustion of fossil fuels are nitric oxides, nitrogen dioxides, and nitrous oxides. The first two of these form the mixture known as the nitrosides, which account for more than 90% of the nitrosides in the main type of large combustion installation. For the hydrochloric acid, the emission of hydrochloric acids is due to trace amount of chloride present in fossil fuel such as coal and oil. Emission of hydrochloric oxide is significant in combustion plant without flue gas desulfurization.
At TMB, supercritical and ultra supercritical power plant operate temperature and pressure above the critical point of water. That shown the temperature and pressure at which the liquid and gases of water coexist in equilibrium. The combustion temperature at Manjung 4 is around 600 degrees Celsius with pressure reaching 270 bars, while at Manjung 1, 2 and 3, the combustion temperature reached 543 degrees Celsius with pressure 165 bars. This helped to reduce the use of coal at Manjung 4 compared with the Manjung 1, 2 and 3. In other words, to create 1000 megawatt, Manjung 4 burns around 10,000 metric tons of coal compared to the Manjung 1, 2 and 3, which is they burn 24,000 of metric ton of coal. The heat rate improvement opportunity for low moisture bituminous coals. For the boiler, potential heat rate reduction for optimized combustion and soup boiling is from 1 to 2%. For upgrade, steam temperature and control capabilities is 1% only. For potential heat rate reduction for recover moisture from flue gas is from 1 to 2%. And for upgrade air preheater is 0.5%. For turbine cycle and cooling system, the potential heat rate reduction install advanced steam turbine, Bolding and seal is from 2 to 3%. And for the heat rejection system, the heat rate is for upgrade cooling system performance is from 1 to 3%, and the total is from 6.5 to 11.5%. Second, the heat rate improvement opportunities for low rank coals and high moisture bituminous coals. First, for the boiler, the optimized combustion and soup boiling is from 1 to 2%. For the upgrade system, temperature control capabilities is 1%. Upgrade air preheater seals is 0.5%. Pre-dry high moisture coals using power plant waste heat 2 to 4%. And recover moisture from flue gas is from 1 to 2%. Second, for the turbine cycle and coolant system, it is installed advanced steam turbine Bolding and seals take 2 to 3%. And lastly, for the heat rejection, upgrade cooling system performance take 1 to 3% for the potential heat rate reduction, and the total is 8.5 to 11.5% for the low rank coals and high moisture bituminous coals. Entropy is a thermodynamic properties like heat capacity and density. Entropy generation is an amount of entropy produced in any irreversible process such as heat and mass transfer processes. Entropy is state function which is changing during a reversible process in a closed system by the ratio Q over T. Entropy increases when T decreases or Q increases. Second law of thermodynamics states that the rate of entropy generation within a system must be greater or equal to the zero. A process for which the rate of generation of entropy is always zero is a reversible process. A large rate of entropy generation corresponds to greater process irreversibility. And as a conclusion, the research has taken information from various sources to understand what is thermodynamic, what are laws of thermodynamic, how they work, and how they make our life easier. It shows that thermodynamic uses devices are very convenient to use. If there were no thermodynamic device in this world, it would be many difficulties to pass a day. By improving the uses and device of thermodynamic, they can make our life more convenient and can reduce the environmental side effect.
I don't know what you heard about me.